In this video, we are going to solve the remaining two questions, that is question 5 and question 6 of 0620 chemistry question paper 42 of the examination series October-November 2024. But before that, let me tell you, you can get more revision material from this app, that is chemscience.in, where you will be able to see the app like this, and you will get ample of revision material resources like notes, videos and revision test, MCQ and subjective questions, past papers, MS and ample more things. So just go ahead and download it from this website, that is chemscience.in. So now let us start with our question 5, that is alkenes are manufactured by cracking larger alkane molecules, and state the source of large alkane molecules used in cracking. Now if we are breaking down large alkanes, what are the source? The major source of alkane is petroleum. From petroleum we get large alkanes which can be broken down further into smaller alkanes. Okay, so the B question is state two conditions. We are talking about two conditions that are needed for cracking large alkane molecules. Now if you want to crack large alkane molecules into smaller ones, we need high temperature along with a catalyst. So high temperature is needed. At high temperature they are heated and along with a catalyst, so it breaks down into smaller alkane molecules. Now if you go ahead still, the C question is when one molecule of dodecane, that is C12H26, is cracked, three molecules of but1N and one other product are formed. So if we are talking about C12H26, that is dodecane, they say three molecules of butene. Now bute itself is C4, and if it is butene, that is alkene, then we have C4H8, because the general formula of alkenes is CnH2n. So if N is 4, hydrogen are 8. So if we have got three such molecules of butene, then we are already done with the 12 carbon atom and 24 hydrogen. So we are left with only 2 hydrogen now. So you can just write hydrogen molecule, that is H2 gas will be formed as a byproduct. So one other product just formed is hydrogen gas H2. Now the second part is suggest the type of chemical reaction which happens during the cracking. Now what is happening is the larger molecules are breaking down into smaller ones, so that's called decomposition. But if it's going on with the help of high heat, then it's called thermal decomposition. So the type of reaction here is thermal decomposition. The D question is propene will undergo polymerization. Suggest the name of the polymer formed from propene. So if propene is polymerizing, then it is polypropene. Polypropene. The way ethene polymerizes to form polyethene, it's polypropene here. Draw the part of these polymer molecule to show 3 repeat units. Now propene is a molecule with CH3 CH double bond CH2. Now I always say that this is the 2 carbon which is the repeating unit which we have to draw. So the 2 carbon I have already drawn. Now we can see that this carbon is bonded to one of the hydrogen, that is this hydrogen, and the other bond is bonded to the methyl group. So we have to draw it down. Okay. Now let me clarify here, this bond has to be bonded with the carbon. So what I have drawn is wrong here. So let me correct. So the way we are supposed to draw is the C should be bonded to C itself. So carbon, then H3. Now this second carbon here, you can see that it's bonded to 2 hydrogens. So we have to draw 2 hydrogens showing all the bonds. Now here they have said we have to draw 3 repeat units. So same way we have to draw 3 more such repeat units. So we are just repeating the same molecule or the same part of the polymer which we have already drawn 2 more times. So here I have drawn one more, and the last one I'm drawing here with CH3, CH, H and H. So these are first repeat unit, my second repeat unit, and this is the third repeat unit. Don't forget to put the extended bonds on both sides, which indicates that there are more monomers to be added here. So this is how you're going to draw the polymer with 3 repeat units for the 3 marks. Here let's go ahead with the next sub question. It says state the type of polymerization propene undergoes. Now this is addition polymerization, because the polymers, or you can say the monomers, are just added to one on the other, and there is no elimination or discarding of any of the atom or molecule. There is no byproduct formed also. There is only one product, that is polymer. So this is addition polymerization. Okay, I have written polymers, so polymerization has to be written. Okay, let's go ahead with the last question, that is question 6 here. So question 6 is polyamides and polyesters are polymers. Polyamides can occur naturally and can be manufactured. Part of the structure of a polyamide is shown in figure 6.1, that is this one. This figure here, a polymer chain is shown. Now on figure 6.1, draw a circle around one amide linkage. So we are supposed to show the linkage of amide, and we are supposed to draw the circle on only one amide linkage. So here is the amide linkage where we are supposed to draw the circle, and here it is shown. You can draw a circle on the other amide linkages also as shown here. Any one will do. I have selected a center one. You can do any one, that's fine. Now complete the figure 6.2 to show the structures of the 2 monomers. Okay, 2 monomers needed to make the polymer in figure 6.1, and here we are supposed to draw the structure, show all of the atoms and all of the bonds in the functional group, they are saying. Okay, so one of the polymer part they have drawn, and the second polymer part is here. Now let's understand, this is a gray box which is drawn here. Okay, the gray box have a C double bond C. So here we are showing C double bond O. Another C double bond O is also present, so that also we are drawing C double bond O. Now what we have to do is we have to break from the linkage, and we have to add the water. So OH will be added to the carboxylic part, and only H will be added to the amine part, that is NH part. So both ways we are going to do this, that is OH has to be added on the carboxylic, that is C double bond O part, and H has to be added on the amine part. So if we draw that way, we are going to have O and H additional here. So here is O and here is H. Now remember what is asked, show all the atoms and all the bonds they have said in the functional group. So we are supposed to show all the bonds here, that is C double bond O, CO bond and OH bond also. Now if we have this single square box which is shown here, we can say that on both sides of this square, white square, we have NH group. So we are going to add NH on both these sides, NH on both these sides, and one more additional H which is going to be added as it's a monomer. During polymerization, this hydrogen 1H is removed as the part of the water molecule. So here this is how we are going to draw the monomer showing all the bonds. So here are the bonds, we have shown all the bonds. The third question now, name the other product formed in this polymerization. Now as I already mentioned that during polymerization water molecule is removed out, so the other product is water, so name is water. If they have asked the formula, you can write the formula as H2O for this. So here name water. So fourth sub question is state the term given to a natural polyamide. Now natural polyamide which exists are proteins. So proteins are the natural polyamides which are present. And the fifth question is name the type of monomers which are used to make natural polyamides. Now natural polyamides we have already seen, it's protein. So the monomers used are amino acids which are added on to each other to form the protein polymer. Let's see what is the next sub question here. Okay, the sixth part. One of the monomers which forms part of the natural polyamide has 3 carbon atoms. Complete figure 6.3 to show the display formula of this monomer. Now they have said that the polyamide has 3 carbon atoms. Now if we draw the 3 carbon atoms, so out of 3 there is carboxylic group, so we have to add 1 carbon with a carboxylic group. Now on the other side of these monomer we should have an amine group, so NH2 group is added here. Now one more carbon atom is left, that has to be drawn here, so CH3 can be added here. Now this is how the 3 carbon is shown. So it's a propane containing 3 carbon atom with an amine group and carboxylic group, and this is the monomer which is used to form the polyamide. Now B sub question is PET is a polyester. Name the two types of monomer molecules needed to make polyesters. Now two types of monomer molecules which form polyester. Now we know that the ester molecule is formed from a carboxylic group and the alcohol group. So the monomers should contain the dicarboxylic groups and the diols groups with the monomers. So these two functional groups will combine to form the ester named as polyester PET. So the two types of monomers should have dicarboxylic molecules and diol molecules. We can also name it as dicarboxylic acids also rather than groups, so that is also fine. Now the second part is draw part of the structure of PET which shows 2 repeat units. Show all of the atoms and all of the bonds in the linkages. Now we are not given any one type of monomer. We are not supposed to show the number of carbon atoms, but we are supposed to show the 2 types of carboxylic acids and 2 alcohol groups in our monomers. So here combining these 2 monomers we should get the polyester PET here. So in general we can draw carbon chain the way it was shown in our earlier question as a polymer. So here I am drawing in general a carbon chain with a carboxylic group on it. So carboxylic group will have CO, but the OH of the carboxylic group is removed out, so only C double bond O is left. So C double bond O is drawn here with an extended bond. Now this gets bonded with the diols group. So out of the diol group the H part is removed, so only O of the alcohols is left. So I'm drawing that O directly here. Here another carbon chain is present attached to the diol. So here is the diol I have completed, but then we are told to draw the 2 repeat units. So here again we will repeat the same carboxylic groups with the carbon chain as shown earlier. So here we are drawing one more, the diol group also. So here we are drawing that and the extended bond to rub out the remaining drawing which I had made and it was confusing us, so I have rubbed it out. So here we have completed the polymer with 2 repeat units. So here is 1 repeat unit and here is the second repeat unit. Don't forget drawing the extended bonds here. So one carboxylic, one monomer with the two carboxylic groups on the other side. The second monomer have again another carbon chain, but will have alcohol groups on the both sides, which are bonded together to form the ester linkage. Now here we are not asked to show the linkage, ester linkage, not allowed to circle, so we are not supposed to show. But if we are told to also mark the linkage, we can draw the linkage or the circle around here, which we are not supposed to draw, so that's fine. So I have also removed it. So here is the end of the whole paper. I hope my explanation is very clear. Also, as I said earlier, don't forget downloading the ChemScience app from the website shown, or it's the description, it's the link is given. You will get access to lots of revision material there, so just go ahead and download it.